Swayam Prabha. Digital India. Educated India.
Good morning, friends, and I welcome you again to this lecture. We are in actually now art pressure topic, and I have just why art pressure and where it is applicable, what are the different types of art pressure, just we have discussed. Those are preliminaries of the art pressure topic. And we have also mentioned that how art pressure at rest happen, how art pressure at active condition and passive condition different based on the movement of the wall, and at the same time because of the movement of the wall and behind the wall the backfill soil will have a particular state of stress, and that of state of stress when the wall moves and develop active case or passive case, based on that the Mohr circle or state of stress changes, how it changes, that I have shown already. And once again I will start from there, and I will show how the relationship between the vertical stress at any point to the lateral pressure when it is active condition, lateral pressure when it is at passive condition. Obviously, at rest condition we have already mentioned, when there is a vertical stress equal to sigma 1, then your lateral stress will be k naught time vertical stress, and k naught actually equal to 1 minus sin phi, where phi is the angle of internal friction of the soil. Now, already by equilibrium or force polygon, both for active condition and passive condition, what are the forces acting on the wall, and then based on that we have done force polygon, and then from there we could find out what is the maximum or minimum pressure, or what is the maximum pressure. When it is minimum pressure, that is active, and when it is maximum, that is a passive, and what is the coefficient, that is art pressure coefficient. All those things we have done. Once again, based on Mohr circle, we can also develop that, and we will see that one by one. So, this is the thing actually what we have mentioned, that this is the ground, suppose this is the top level surface. So, we are actually discussing right now about the Rankine's theory, where Rankine's theory initially assumed that vertical wall and no friction between the wall and the backfill, and there is a horizontal backfill surface is not sloping like this. So, horizontal. So, this is the condition generally applicable for Rankine's theory. Of course, if it is a sloping surface etc., and backfill also inclined, some way after doing some modification we can apply Rankine's theory also, which I will see this later on. Right now, suppose this is the backfill and this is the wall and this is the backfill. So, at any point here we have sigma 1 equal to gamma times h, the depth is h, and lateral stress will be sigma 3, suppose we do not know. And now, if the wall moves this direction, then the sigma 3 will be slowly reduce, and that will reach and finally reach to a minimum value, that is actually your that is active stress, and similarly at that time your sigma 3 will be the minor principal stress. And if the wall moves this direction, then this sigma 3 will be slowly increasing and it will reach to a maximum value, and that is actually maximum, that is the lateral earth pressure. And by that way the sigma 3, though it is termed as sigma 3, but in the passive case sigma 3 become the major principal stress because it is bigger than this. So, that I will take in the subsequent figure or in the pages. Let me go to the next slide. And so, if the if that is the one, once again I will just, this is already we have shown, but once again repeat here. So, suppose sigma 1 is here, and then because of the movement of the wall from the backfill, the stress is reduced and finally is here minimum value. So, this circle corresponding to the active case, and this is the phi. So, this will be the envelope. So, this point, tangent point, and this failure point, these two joining this line, this will be usually the failure plane, which will be equal to 45 degree plus phi by 2. And passive case, when the wall moves, then sigma 3 will be slowly increasing, and at some time it will reach to this value at the verge of failure, and then you can draw more circle. This more circle is corresponding to passive case, and then this is the failure stress, and then from there to tangent to this, if you join, this is the failure plane, and this failure plane will make an angle 45 degree minus phi by 2 with horizontal. So, these are the basic thing once we have done, but once again I will repeated this one, and corresponding to this you can see sorry. So, when you active case, that is pressure is there, then your failure planes actually it will be in this direction behind this 45 degrees all are parallel, and this is the state of stress at failure. Similarly, when it is a passive, this is the state of stress, and the failure plane will be like this. These are the failure plane, and this making angle of 45 degree minus phi by 2, and this is the state of stress. Now, extracting from there, I am extracting the active case only. That means active case means what? This was the initial pressure, and then because of the movement of the wall, it reduced to this value. So, this is the major principal stress, the minor principal stress at failure, and then this so with this I can draw a Mohr circle, and since it is at failure, then your failure envelope will be tangential to this. So, this angle is phi, and now based on this Mohr circle, this is sigma 1 equal to gamma h, and up to this it will be sigma 1 and this is sigma 3. So, this must be sigma 3 plus sigma 3 plus sigma 1 minus sigma 3 by 2, which will be giving you this value. So, that means this one is sigma 1 plus sigma 3 by 2. Now, based on this, if I consider now this triangle, this is suppose O, A and C, this triangle if I consider, and I consider this sin phi, and this is right angle. So, based on that I can write down the expression for sin phi, and from that sin phi I can relate sigma 1 and sigma 3 and phi. So, sigma 1 and sigma 3 will be related to only sigma phi, because that phi is the function of, for granular soil, is a function of coefficient of active earth pressure or passive earth pressure. So, that one we will see that the next slide. So, if I take this angle, and your sign is this one. Sign means actually this by this. Okay, sign is actually this by this. Sorry, this by this. This by this. So if I do that, you can see next slide. See, sin phi equal to that is radius by that center to the radius, the origin to the center of the circle. This is the one, and this is the, so this circle was like this. Not. So this was sigma 1 minus sigma 3 by 2, and this one was sigma 1 plus sigma 3 by 2. So this by this, actually this is right angle. So this by this actually your sin phi, this is phi. So based on that I have written here sin phi, and then if I little simplify, then will sigma 1 minus sigma 3 by sigma 1 plus sigma 3, and further simplify, and if I express sigma 3 in terms of other, then the expression reduces to this form. You can see sigma 3 equal to sigma 1 into 1 minus sin phi by 1 plus sin phi, and sigma 1 is what actually gamma h. So gamma h time this, and this can be written as, that can be written also gamma h Ka, where Ka equal to coefficient of active earth pressure. So that means if you have this is the wall, and at this point you know if the gamma is here. So at this point your if I draw the vertical pressure diagram, so it will be something like this, gamma times h, and if I want to draw active earth pressure, then I have to, it will be something like this. How it will be? This will be actually gamma times h into multiplied by Ka. So if I multiply by Ka, then I will get the, if I draw vertical stress at different point and draw a line, that will be vertical stress diagram. This is vertical stress diagram, and this is active earth pressure diagram. So vertical stress and active earth pressure, how they are related? Just multiplication of gamma a. You can see here gamma h into this, and this is nothing but Ka. So gamma h Ka is the sigma 3, and this is nothing but, this is also can be written as your Pa. I can write as a Pa, active earth pressure intensity. This can be also written as Pa, active earth pressure, equal to gamma is tan square 40. So 1 minus sin phi by 1 plus sin phi equal to tan square 45 degrees minus phi by 2. That is the way also can be. So the main thing is here we could from the active case, and by using Mohr circle we could establish the Ka expression equal to 1 minus sin phi by 1 plus sin phi equal to, that is also tan square 45 degree minus phi by 2. Either way, either you can use this expression or you can use this expression. Okay. So this is actually we have got now expression for active earth pressure coefficient. Next is, if I go to this one, the passive case, you can see again this is corresponding to passive case. It sigma 1 was here, and then slowly because of the pushing towards the backfill, the lateral stress increases, and at failure suppose this is the value sigma 3. So though this here it is written as sigma 3, but it is actually major principal stress. Because of that, suppose we have taken as a sigma 3 dash. Okay. So now this is the failure. So that means this and this together by using this point on the Mohr circle, and we can draw the Mohr circle, and now we know that at failure Mohr circle will be tangential to that envelope. So, we can draw the envelope with angle phi, and then we get this one. So, like previously what we have done, this is O and this is O, A and C. If I take this triangle, again this is right angle, and again I can write sin phi, then it will be equal to this by this, and this one equal to sigma 3 dash minus sigma 1 by 2, and this will be again sigma 3 dash plus sigma 1 by 2. So, it is almost similar. Only sigma 1 and sigma 3 location is changed. Now based on this I can write again expression for sigma sin phi in terms of this and this, and then simplify and get the relationship between sigma 3 dash and sigma 1. So, if I want to do that, you can see now sin phi will be equal to this radius by this distance. So, this is already I have shown there. So, that means if I have this one and this one, this is the center of the circle, and so this is right angle, and this is actually your sigma 3 dash minus sigma 1 by 2, and this one is sigma 3 dash plus sigma 1 by 2. So, this is the this by this actually sin phi for here, this is phi, and then simplify it become this. Now, if I extract now sigma 3 in terms of other parameters, then it become like this, sigma 3 dash become sigma 1 multiplied by 1 plus sin phi by 1 minus sin phi. So, it is gamma h 1 plus sin phi by 1 minus sin phi. This can be also written as gamma h your gamma h k p. Okay. So, this is also can be written as p p, this can be written also as a p p. Okay. So, p p equal to sigma 3 dash gamma h square tan square 45 plus by 2. So, this that means k p equal to 1 plus sin phi by 1 minus sin phi. And now, pressure diagram, suppose this is the ground, this is the ground, and at this point I have to find out the pressure diagram. So, vertical stress distribution will be something like this. Suppose at this point this will be gamma times h, and if I want to find out K p, then K p will be something this one. This is actually passive pressure diagram, passive pressure diagram. Okay. And passive pressure diagram, how to get? Passive pressure diagram will be equal to vertical stress multiplied by coefficient of passive earth pressure. So, this is the one. So, there actually in active case the value, since K always less than 1, so it was lesser this side. Now, K p is always greater than 1. So, it will be higher than that. So, diagram will be like this. So, we have got now from the Mohr circle K p we have got, and you can recall we have got K a equal to 1 minus sin phi by 1 plus sin phi. So, you can see from there K a will be nothing but 1 by K p. Okay. So, if you have phi equal to 30 degrees, then you will see K a will be 1 by 3. If I put phi equal to 30 degree in this expression, you will see 1 by 3. So, K p will be actually in that case K p will be 3. Okay. So, generally in the passive case, that means in passive case your earth pressure on the wall will be significantly high. Now, so these are the things based on Mohr circle actually at failure both at active case and passive case, we could establish the coefficient of active earth pressure Ka, coefficient of passive earth pressure Kp, and their expression is 1 plus sin phi by 1 minus sin phi, or 1 minus sin phi by 1 plus sin phi. So, these things we have now got it. And you can see now, as already I have shown, here also it is shown here. Suppose this is the wall and this is the backfill, and backfill soil has unit weight equal to gamma, and if I consider this is H, then your vertical stress distribution could have been with depth. If I could have got vertical stress distribution, so it will be something like this, and at this point it will be gamma times H. Okay. And if I want to find out the active earth pressure diagram over the depth, then simply you have to multiply by Ka. So, this is the thing is done here. So, this is not this is actually, I can say, Pa at this point will be gamma H Ka. So, this is the gamma H Ka. Now, if I want to find out the thrust on the wall, that means total thrust because of this backfill pressure, if I want to find out, then this is the pressure acting on the wall assume, then when I have converted the soil pressure by this active pressure, then we can assume that soil is not there now. Now, because of this pressure or this loading on the wall, what will be the total force? That can be that is nothing but the area of this diagram. So, if I find out the area of this diagram, it will come half multiplied by the base actually half actually into Pa in multiplied by the H height. So, equal to half Pa is what? Gamma H Ka and multiplied by H. So, it would be ultimately half gamma H square multiplied by Ka. So, that means if I know the unit weight of the soil, then from the unit weight I can find out vertical stress at any point, and then if I know the phi of the soil, I can find out the coefficient of active earth pressure, and then coefficient of active earth pressure multiplied by the vertical pressure will be the lateral active earth pressure. Now, at different point I can calculate, or you can find out the lateral earth pressure like the way I have done here, and then I will get if there is a single layer of soil, then it will be continuous and diagram will be triangular, and once this diagram is obtained, then you need to find out, suppose total thrust because of this backfill pressure, then what you have to find out? You have to find out the area of this triangle. So, area of this triangle is nothing but half multiplied by Pa multiplied by H, and half gamma H K. Pa is gamma H K and H. So, half gamma H square Ka. So, this is the way one can find out. So, that thrust, suppose this entire triangular diagram can be suppose expressed by this one diagram. So, this is the thrust. So, when we assume a triangular pressure converted to a thrust, that means it will be also has to work at a particular point, then only it will be equivalent. So, that means we can find out also where the point of application, when there is a triangle, then that force must be acting through the center of the circle. So, there actually center of this circle of this triangle will be from the 2/3 height, or sorry, from 1/3 height. So, from here, from the base h by 3 distance it will be. So, that means these are the things we can remember, that this thrust, this when there is a backfill, then because of this backfill there will be a total thrust which is equal to the area of this triangle will be acting there, and the point of application will be 1/3 of the height of the wall from the base, or if it is taken from the top, it will be 2/3 from the 2/3 of the height of the wall from the top. So, this is the one or it can be used for various calculation later on. So, these are the certain things can be kept in mind. So, next is, suppose there is a water table somewhere here. Earlier it was a suppose dry cohesionless soil, and here it is suppose water table up to this. That means this is saturated and beyond that suppose dry. So, here if it is a gamma T, so this will be at this point your pressure diagram, active earth pressure diagram P A will be equal to gamma T times this is H1 multiplied by K. So, this is the thing is written here. So, at this point this is the value. Now, from here when you go beyond, then that pressure will be there already, In addition to that, from here to here whatever the soil pressure will be added. So, that how to find out that? I can take this is the reference now, and if I go at H from here. So, how to find out? That is actually effective pressure you have to consider, and if you have the if the saturated unit weight for this soil is suppose gamma T, and then your submerged unit weight or effective unit will be gamma T minus gamma W. So, from here actually suppose I want to find out this point, this one will be equal to, and it is will be equal to gamma T minus gamma W multiplied by H. So, multiplied by K. So, this will be added, okay. And this is actually can be written as submerged, gamma submerged. So, that means we can write gamma submerged H K. So, that means when I will come from here to here, so how much it will be? This height is H2. So, gamma submerged into H2 multiplied by Ka. So, I am getting from here to here, because of the soil weight I am getting this component, and from here to here I am getting this one, and once this pressure is applied, this pressure will be also up to this already there. So, this pressure will be there, additionally because of this soil will be added. So, diagram will be like this. So, that means I get a pressure diagram which is not a uniform triangle like previously I have got a triangle here. Now, I can make this a trapezoidal I can consider, or I can consider one rectangle and one triangle. So, in 3 parts it is easy to make it. If I make it 3 parts, it is easier because the triangle and rectangle CG is known. So, if I want to find out the thrust, then it is easy to find out the thrust, and then to find out the thrust, and suppose this is Ka is not known, suppose the phi value is given, from there we can find out what is the value of Ka. And so, another thing is because of this soil pressure we have got this diagram, and but because of this water there will be again thrust. So, separately you have to draw the water pressure diagram here. So, from here water table is 0. So, it is pressure is 0, and when you go at this level you will get gamma W times H2 as a water pressure, and active earth pressure for water is 1. Active earth pressure for water is 1, whereas active earth pressure for soil depends on phi value of the soil. So, if the phi value is known, then one can find out Ka. Sorry, this is not equal. If it is phi is known, that gives you Ka. So, Ka value can be anything like your 0.3, 0.4, 0.35, all those things. So, I can find out the Ka, and this is for water Ka is 1 always. So, now if I want to find out the total thrust on the wall, then what I have to do? I have to find out the area of these 3 parts plus area of these 3 parts, and then if I want to find out the point of application of the thrust, then I have to find out the CG of all 4 parts, 1, 2, 3, 4, 4 parts. I have to find out the CG, and there is a calculation procedure how to find out the CG. So, this force will be acting at the midpoint, this will be at h by 3, this will be h by 3, this will be also h by 3. So, this distance will be known, 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 this value also 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 will be known. So, all values are known, all individual lever arm is known. Then if the thrust is acting somewhere here, what is the thrust? This is if I consider this is P1, this is P2, P3 and P4. So, your thrust PA will be equal to P1 plus P2 plus P3 plus P4. So, this will be finally PA, and what is the distance that actually you can find taking the moment all respective load with respect to a point, and the taking that will be balanced by this load moment of this load to the same point. So, that procedure I will show you later on. So, if there is a water table, this is the difference actually. If there is no dry coherent soil, simply you will get the vertical stress diagram will be equal to gamma times H, and active pressure diagram will get gamma times H into Ka. And now, if you want to find out the thrust, just find out the area, and if it is a suppose the water table is there, then above water table you will take full unit weight, but below water table you have to take submerged unit weight to find out the soil pressure, and that is one part. And also again you have to consider water pressure also and separately, and that water pressure will be again we know the water pressure diagram to 0 at a water table at atmospheric pressure, and to depth it will be gamma W times H, and for water actually K will be 1. So, if you want to find out the total thrust, you have to all areas pressure diagram to be added, and to find out the thrust you have to find out the individual point of application, and then from there taking moment of the resultant and the all other forces, you have to find out the unknown distance or point of application. So, this is the way one can find out the active earth pressure thrust and their point of application. So, with this I will stop here. Thank you.